In this video, we're going to go through some practice problems in naming compounds and writing formulas. So for each one of them, if it's given you a formula, you're going to write the name, and if it gives you the name, you're going to write the formula. And so the format will be like this. You'll see the formula or the name appear on the screen, and then I'll give you a couple of seconds to answer it, so you might want to hit pause if you're watching this at home, and try the problem, and then we'll walk through how to do it. So the first one is, there we go, CSBR. So for CSBR, we have just two elements. This is referred to as a type 1 binary because cesium is found in group number 1 of the periodic table. So naming this is simple. It's cesium, and then for the negative ion, the anion, we ended in "ide." So this is simply cesium bromide. All right, next we have iron 3 nitrate. So we're going to write the formula for that. So for this, we're going to take iron, which is Fe, and the 3 tells us the charge of it. So I should have it. There we go. Iron with a +3 charge, and then nitrate. If it ends in 8, remember to look it up on the chart. It's a polyatomic ion. It's NO3 with a -1. We're going to crisscross these numbers to find out what the subscripts are. So 1 goes down here with iron, 3 goes down here, and that's 3 of the whole nitrate. So it's going to look like this. This 3 went down outside of the parentheses, so it's Fe parentheses NO3, close the parentheses, 3. All right, the next one, SF6. Okay, this consists of sulfur, which is a nonmetal, and fluorine, which is a nonmetal. So we're going to go to the type 3 rules. The type 3 rules are to put the prefixes out in front of stuff. So this is sulfur. This is fluorine. It's the negative ion as written here. So this is sulfur hexa, which means 6, fluoride. All right, now we do some acids. Hydroselenic acid. If it starts with hydro and ends in ic, that means there's only 2 elements, hydrogen and whatever this is selenium. Well, if we look that up, we find selenium is -2, so there's 2 hydrogens. So H2Se. Next, dinitrogen pentoxide. If we see prefixes, that means it's 2 nonmetals. In this case, nitrogen, of which there are 2, and oxide refers to oxygen, of which there are 5. So N2O5. N2O5. H2CO2. This one starts with a hydrogen, so we should think about acids. It's got an oxygen, so that means we're going to look up what CO2 is. CO2 is an ion called carbonite. And in an acid, if it ends in "ite," the acid name ends in "us." So this is simply carbonous acid. CO2 is carbonite. Ite becomes "us" in the acid. Next, sodium sulfide. Yeah, emphasize the "ide" because "ide" tells us that it's just sulfur by itself with a sodium. So we look up sodium, we find that to be +1. Sulfur is 2-. Crisscross these numbers down. 2 to the sodium, 1 to the sulfur, Na2S. Potassium sulfite. The "ite" ending tells us that there's going to be an oxygen, so this is a polyatomic ion. You can look it up on the periodic table and find that sulfite is SO3 -2, and potassium is, in the first column, it's +1. So +1, -2, crisscross this number down here, the 1 goes down here, we have K2SO3. MnO2. For this, we look at manganese and find that manganese is in the transition section. If you use your Turk, you will find that manganese has a couple of possible ion charges. We have to figure out what that is. So we look to oxygen and find that oxygen is -2. There are 2 of them. 2 times 2 is -4, which means the manganese has to be the +4 to make that work out. So this is manganese 4 oxide. And this is the last one, NH4C2H3O2. When we see a big mess like this, we should start looking for groupings. So you may recognize that NH4 is a group, a polyatomic ion called ammonia, and C2H3O2 is a polyatomic ion called acetate. If we have 2 polyatomics, we just name them ammonium acetate. Ammonium acetate. Of course, you can go back, stop, start, pause, rewind, watch all of these you need to. You have examples of all different kinds of the naming that we're going to have in this chapter.